Hello, ladies and gentlemen. Today we are going to be proving other things than just the two triangles are congruent, and that is something called CPCTC, and you'll see what I mean in just a second. But other than that, you'll just need your notes and a pen or a pencil. So you do not need to write this slide in your notes, but this is a proof of something that looks like what we've already done. So we've been given the information that AB is congruent to BD and that BC is congruent to BE, and then we found that these two angles are vertical angles, and we wrote that in our proof. So then by side angle side, we can know that the two triangles are congruent, and we proved that. That was the reason for the proof, was to prove that these two triangles are congruent. But what if we didn't just stop there? What if we, instead of proving that the two triangles are congruent, tried to prove something like this? Angle A is congruent to angle D. If we know that the two triangles are already congruent, then from our congruent statement, back when we learned about congruent figures, we know that angle A, and I'll put it in red here, angle A has to be congruent to angle D because the two triangles are congruent. So the corresponding parts of those two triangles are congruent. So if we had that as our proof, then our last statement wouldn't just be the two triangles being congruent. It would be angle A is congruent to angle D, and the justification is the whole point of today. That's where we're going with this. So you don't have to write this slide in your notes, but that was just a mental check of what we're doing. So this is where you can pick up your pencil, and this is the big definition for today's video, or the main goal or point. So if we have that two triangles are congruent, then their corresponding parts of the two congruent triangles are congruent. So what we're saying is if in our proof we found that two triangles are congruent, then the corresponding parts of those two triangles are also congruent. So if we look, that's the definition of CPCTC, which is what we were talking about today. We're going to be using the proofs of two congruent triangles to prove other parts of triangles are congruent. So if we look at our two blue triangles down here, we have triangle ABC and EDF. So we know that these two triangles are congruent because we have three corresponding congruent sides, right? We have AB is congruent to ED, AC is congruent to EF, and then BC is congruent to DF, those segments. So our question then is the angle B, this angle right here, congruent to angle D? Yes, those two angles are corresponding angles according to the two congruent triangles. So yes, they are by CPCTC. All right, so we have just 3 proof examples today. So when we get to each example, you can pause the video and take a second to write the image in your notes, and you can just write your statement and reasons columns. You can choose to write the given in proof, but I would for sure make note that you get the picture and then our 2-column proof in your notes, and that'll be for 3 examples. So we have the given statement in our proof statement. We've been given the information that AB, line segment AB, is congruent to line segment CD, and that the angle BAC is congruent to the angle DCA, which are these two right angles in this diagram. And so we have to prove that the line segment BC is congruent to the line segment AD. Although we might know it already off the top of our head that we have two congruent triangles, we want to formally prove it in our 2-column notes, or in our 2-column proofs, excuse me. So in our 3rd step here, we've already filled in the given information. We know that AC is congruent to AC by the reflexive property. We've been doing this quite a bit, so this should be easy to recognize that right away, that this is naturally our next step. So fill that in. And now we know by side angle side that we have two congruent triangles, right? We know that triangle BAC is congruent to triangle. If I started with B, I need to start with DCA. We want to make sure that our congruent statement has corresponding angles and side lengths, right? So if I started with BAC, then I have to do DCA for my 2 triangles. So now that we have that the 2 triangles are congruent, we can then say that line segment BC is congruent to line segment AD because of corresponding parts of congruent triangles. They are congruent. So our last step is by CPCTC. All right, so for our second example, we have this image and we have the given statement that AB is congruent to DC, line segment AB is congruent to line segment DC, and that line segment AD is congruent to line segment BC, and then we are trying to prove that angle A is congruent to angle C. So let's get my given statements written down. Line segment AB is congruent to line segment DC. That was given to me. And then I was also given that line segment AD is congruent to line segment BC. And luckily, they're already marked on the image for me, so I don't need to make little slash marks on those line segments. But the next slash mark, or the next tick that I can make on my image, is that the line segment BD is congruent to, BD is congruent to itself, line segment BD, and that is, once again, by the reflexive property. And this should be getting easier, these steps. And now we know from our image, the next step that we know is that our two triangles are congruent by side, side, side. So now we have to make a correct or a accurate congruent statement before we can just jump to our proof statement. So if we just start with this triangle right here, I'll say triangle ABD is congruent to, if I started at point A, went to point B, and then to D, now I need to do for my other triangle, I need to start at point C, and then I need to go to D, and then to B. So it's triangle CDB, because that's the corresponding parts for both parts of the triangle. So I paired them up so that my congruent statements make sense, and so because of that, now I know that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. CPCTC. All right, so for our third and final example, we are going to be looking at something a little different than the last two. So keep your headphones in and keep paying attention. I want to thank you for taking good notes. We're going to start with writing our given statements as always. So line segment KM is perpendicular to the line segment JL. That was given information to me. Remember that this upside down T means perpendicular to. That's how we read that. So we know then, and it's already drawn in our image, that these two angles, which I'm going to label angle 1 and angle 2 just for convenience, are 90-degree angles. That's what perpendicular means. So moving on, the second statement we're going to write is that JK, the line segment JK, is congruent to the line segment KL, and that was given information for me. So we know from the definition of perpendicular that the measure of angle 1 and the measure of angle 2 are 90 degrees. We know that, but we don't have it written in our statement column. So we can't just assume that everyone knows that when we're trying to prove things. We have to write down everything that we know. So we know by the definition of perpendicular, and I'm doing shorthand and you can too, that the measure of angle 1 and the measure of angle 2 are right angles. They're right angles. I'm just going to write that. And because they both measure 90 degrees, we know that they're congruent. So that's all in one step by the definition of perpendicular. Awesome. Okay, moving on. We know that this is once again a reflexive property. KM, the line segment KM is congruent to itself, KM, by the reflexive property. Okay, and then we have two sides and an angle. Well, if I remembered, SSA or ASS didn't work. But remember we said 90-degree angles here for our angles. That means that these two triangles are right triangles, you guys. So that means that this is actually a hypotenuse and a leg. So if we have two triangles that are right triangles with a corresponding congruent pair of a leg and one pair of congruent hypotenuses, then we know that the two triangles have to be congruent. So by the hypotenuse leg postulate or theorem, we know that these two triangles are congruent, even though it's angle side side. Remember, HL is a special case of angle side side. So triangle JKM is congruent to triangle LKM. Remember, I just followed the order from the first triangle that I started. So that's not what we were trying to prove. We were trying to prove that M is the midpoint of JL. So from the two triangles being congruent, now I know that the third side has to be congruent, right? That's my next logical step in my thought process, is that every corresponding part of these two triangles are congruent. So let's write that down. Line segment JM is congruent to the line segment ML by corresponding parts of congruent triangles being congruent. So we know that, but that's still not my proof statement. I'm trying to prove that M is the midpoint of JL. Do I have enough information now? Yes, I do, because we just said that JM is congruent to ML, which makes M the midpoint of JL. So now I can say that M is midpoint of, and I shortened midpoint of JL by the definition of midpoint, because I already talked about how those two line segments JM and ML are congruent. So therefore that makes M the midpoint of those two. I want to thank everybody for taking good notes, and I will see you tomorrow.